Sharp tools bring joy to wood turning. Dull tools equal frustration. My name is Dennis Belcher. I've been a member of the AAW for 20 years. I'm currently a member of the Wilmington Area Woodturners based in Wilmington, North Carolina. This recording goes along with my article, An Introduction to Sharpening, that has been published in the American Woodturner. We're going to talk about some of the critical aspects, and I'm going to try to use a mix of systems, a mix of different type of wheels to give you a feel for the critical elements regardless of what your specific situation or system is. Because one of the things that you need to remember is amongst all of these choices in sharpening systems, they all work. All of the systems will take abrasive substance and move it across your tool, removing metal, okay? Now, that's an issue because as you remove metal from that tool, it's got to go someplace. Where does it go? Well, on a CBN wheel, you can take a magnet and put beneath the wheel, and you can pick up a lot of those metal particles as you see here. But you're not going to get them all. And if it's a friable wheel, you can't do that. It won't work. So where do those particles go? Well, we don't want them to go into our eyes or our lungs. So the first thing we're going to do is put on safety glasses or a safety shield to protect our eyes. On our lungs, we have a couple of choices. My practice is to use either a N95 mask like this for short duty, for short times, or to go to my VersaFlow 3N helmet, which is a combination of a safety shield along with a filter that goes behind my back, rests down at my waist, and removes basically 100% of all the particles in the air. Regardless of how you do it, remember you are putting metal into the air and it's going to end up someplace. All right, now, couple things that we need to kind of address. One is lighting. It's very important that you be able to see well, because as you bring that tool into the wheel, you need to be able to see the exact spot where it meets the wheel to make sure it's aligned correctly. If you don't have adequate overhead lighting or shop lighting, general shop lighting, certainly a work light, at your sharpening station is appropriate and should be done. Height is important. As you do these motions, you need to be comfortable. My suggestion is that your sharpening station be at the center line of your lathe or higher. And that minimizes how much you've got to bend over to check how that tool is doing against the wheel. Next safety issue is the common mistakes that happen in sharpening. And really there's two of them. First is a failure to engage the lockdowns. And it's kind of one of those things, you just have to form good habits. Just as you learned you got to lock down your banjo. But when you go to a lathe, you've got to make sure that you have taken the time to engage all of the hold downs before you turn on the motor. Critically important that you do that. The second safety consideration in sharpening is going off the wheel. Now, what happens when you go off the wheel is something that looks like this. You're sharpening your gouge and you get turned over too far and it goes in, and I don't know if you can see this well, but you catch the edge of the wheel. CBN wheels are typically either aluminum or steel. And let me tell you, when you get a catch with a metal wheel, you're going to hear a kabang! And it's a lot different than a catch on wood. It's one of those things you do it once, you don't ever want to do it again. So now, the good news about that is that the current generation of sharpening systems have addressed that issue. And we're going to be using this one today. All right? And what they've done is they figured out a way to hold these so it won't go off the wheel. And that's very, very, increases the safety tremendously. Now, the second thing that's important is repeatability, because the most important thing about a grind is it be the same one as you had the last time you used the tool. You know, there's a lot of different opinions out there about grinds, and they're held very, very fervently. But at the end of the day, the most important thing is the grind that you use today is the grind that you used the last time. Now, on this particular system, one of the things that becomes very obvious, it really begins to improve your repeatability. And the way they do that is they have on the bar in the base notches, which are numbered 1, 2, and 3. Now this is worn away a bit, but those notches won't wear away. And they have a guillotine here that allows you to put this base arm back into the sharpening system is exactly the same place each time that you use it. Now you have to remember that when you talk about sharpening a bowl gouge, it's a pretty complex curve. You got the curve around the tip. You also have the angle here on the tip and on the wings, and you have a third one which is the shape of the tool as it comes around the tip. So it's rather complex. So to be able to handle that complexity of gouges in general, what you have to be able to do a couple of things. First thing that you do is you have to make sure that the tool is in the jig at exactly the same place each time that you use it. On this particular system, it comes with a built-in measuring spot. On older systems, what I have here is, you can't see it, but what's there is a block that's 2 inches back from the edge of the grinding station, so I can put my tool in there and lock it down and get exactly the same spot. Okay, second thing that happens here is, so we've set this distance. Now we have to determine how far away from that wheel we want the tool tip to be. Now this particular system comes with some recommended settings. My experience is I actually didn't like those settings. I have a tendency to like a little bit blunter settings, grinds than a mini. I think it's a little bit friendlier for folks. So as we come to this system, what I would suggest you do is take a sharpened tool and that you're comfortable with, put it in here, and begin to adjust the wheel until you find a spot that is pretty close to what you're used to, or exactly close to what you're used to. And that's what I have found. Now, this is not the recommended setting, but it is a setting that I'm comfortable with and accustomed to. And it's the accustomed to that's the important part. Now, let's see. Are we ready to sharpen? Next thing I have to do is engage the lockdowns. Check that I have no obstructions on the wheel. I've got my safety goggles on. And we're going to turn on the wheel. Now I don't come straight into the wheel. Rather what I want to do is I want to come in at about a 2 or 3 o'clock position and grind back the wing. Go to the other side and come in at 2 or 3 o'clock and grind it. And then merge the two by going across the tip. The reason for this on all tools is that if we start with it right on the tip, we're going to grind away metal too much, too fast, because there's really not a lot of steel there. And then it takes forever to get the wings to come back into a good place. Now comes the most important part of sharpening your tools, and that's the turner's look. And I'm going to look at that. And I'm going to look for any facets. I'm going to make sure I like the tip. And if it's good to go, if it's a good grind, I'm going to take a picture of it, paste it on my grinding station, so the next time I do the same tool, I have a reference to come back to. That's very important, that you have a reference to come back to. Okay, now that we've got this sharpened on a CBN wheel, let's go to a friable wheel. Now, friable wheels, and here, come in a lot of different colors and grits. This is a ceramic friable wheel. This is an aluminum oxide wheel. This is blue. This is white. This is a little finer. This is a little coarser. And this particular system I like in that it has graduated indents and markings so that this particular tool is set on a 7. And if I look down here at the base, I have the same markings down here at the base. This is set at 90. So I can return to the grind that I had without any difficulties. But the problem is that this wheel changes diameter. So the question becomes, how do we make sure that this tip is positioned on that wheel in exactly the same place when the wheel itself keeps changing? Well, the resolution to that is the jig. Lots of different jigs out there. This one gets you pretty close because it has indexing on the base itself. But there are jigs, both commercially made, like this one, which I can set down here in the holder for the jig, bring it up, place it here, loosen that up, look at this, and that is at a 3. So I can adjust the bar so it always comes back to this position. That's very important. It doesn't have to be a commercial jig. There's a number of jigs out there that are shop made that work just as well. So sometimes a jig that measures from the wheel to the pivot point of the jig that holds the tool are very important. Now that we have that, going to set it in the base, bring it up to the wheel. But one of the things that happens with this system or other similar systems is that spacing is never exact. So to make sure that I'm dead on, I'm going to take a black marker. Now, it's very important to be black. Not really. It could be any color you want. But I'm going to go ahead and color the tip of that tool like this. And I'm going to come back on the wings also. And when you get done, what I have is a blackened tip. Now, the reason for that is that allows me to put the jig in the base, bring it up to the wheel, turn it by hand, and I look. And what I see is a line. I can see metal again. That black has been removed consistently across the tip. I'm dead on. If part of that black was still on it, what I knew is I would have to adjust my base in or out to make it get back to where it's supposed to be. That's very important. Okay, we're good to go. Put it in the base, check the lockdowns, look for loose things that may interfere with the wheel. Now, one of the things that is kind of important is that if you look at how I hold this, the closer you have your hand up here, the better control you have over the wheel. If you hold things back here, okay, you're more inclined to have a problem. Put your hand up there where it's somewhat close to the wheel. Don't get too close to the wheel, but where you've got a firm, easy point of control. Turn on the wheel, come in at 2 o'clock, do the wings, come back the other way, do the wings. Now I'm still seeing some black, so I'm going to come back and do the wing, come back and do the wing, merge the tip, now we go back to the same key thing, and that is I am going to actually look at that tip and make sure that it's what I'm accustomed to. And it is, so I'm good to go. Now, I don't care whether a bowl gouge is a 1/4-inch bowl gouge. I don't care whether it's a 3/8 bowl gouge. I don't care what the flute is. All of those tools sharpen exactly the same way. Spindle gouges are a mainstay of all spindle work. They come in different sizes, an 1/8, 1/4, 3/8, and a half. All are sharpened basically the same way. Now we're going to change systems up here again. We're going to switch from this short bar system to a longer bar system. Okay, much the same, except there's no slots in here to repeat the positioning of the bar. We slide it into the base, slide it up. Now let's talk about the jigs that are used with this system. This is what it looks like. For a close-up view, let's go over here. Now what we have here is a pad, nylon pad that comes across, down across the flats of the wheel. Now, one of the problems you run into is with time and usage and repeated sharpening, your gouges get shorter and shorter and shorter, and there's no longer a flat, it becomes a round. The way I've resolved that on this tool is to go in with an angle grinder and simply flatten it out in here so there's a place for that pad to go to lock it in. So we're going to go up to the same place as we have before, and to my block 2 inches back off the edge of the turning station. That varies from system to system, so be careful and get it correct, attuned to your exact system. We're going to bring it up, and let's talk more about what this wing does. This wing controls the grind on the side. Now, there are notches here that are not numbered, but there are notches. What I did some years ago is I went to the one side of the jig and I etched a line for each of my tools that I use this jig with. So this is a 1/2 inch bowl gouge. So I find the line that says 1/2 inch, and by the way, that is also 1, 2, 3, 4, 5. It's the 6th notch. So, but these control the side grind. Now we have to make sure that the distance from here, to the wheel is what it needs to be. You have various different ways to do that. There are a number of jigs out there. This is one that's available, comes in like this to help you position the wheel. Another one is this one, which is you can use with all your different tools, and you simply put it in a pocket, come up, and it will measure that, and it has a scale here. So I can write down the fact that this particular spot is a 3 and lock it in, and I'm good to go. Or we go back to the way that we've worked at before, which is to take a magic marker and to darken the tip of the tool. Now this is not as precise as some of the current generation of systems, which is one of the reasons that this gouge is as short as it is. So I'm going to put that up against the wheel, turn the wheel, and I look and I said, no, that's not right. I've got to bring the wheel up. It's cutting on the tip. Turn it again. Now I'm on the heel, so somewhere between the two is where I should be. Now I've got it, it's all the way across the magic marker, so I'm good to go. I'm going to turn on the motor after I've checked the lockdowns and made sure that there's nothing loose around the grinder. Come into the 2 o'clock position, do a wing, go to the other side. Again, the closer up you get your hands to the tip, the better control you have. 2 o'clock, bring it back, check it, round the corner. And as always, I'll look at it with the sharpener's eye and say, well, need a little bit more over here on this side because it's not even. So I'll bring it down and I'm done. This is not the only system. If we go back to the one we've used before, which is this system, this is a little different. Here, what we have is we have numbering from 1 to 8. A spindle gouge should be set somewhere between 4 and 8. And so I can loosen this knob. Now each of those numbers has back behind it an indent. So you can move it up, move it up. I mean, you're going to come back to the same spot each time that you adjust it. So I'm going to put it back on the 4. Hold it down for a minute while I engage the tightening nut. There we go. Same issue, that we have to make sure of our distance from here to there. We put it in the pocket. Now you notice now I'm interchanging systems and it works still just fine. And I'm going to go check this distance from here to there will be different because it's a different system. So I come up, check my grind, bring the bar back, there I go. Now I have the same issue. Either I have to use the magic marker system or I have to use some type of a jig to make sure I'm in the correct spot. The interesting thing about this particular one is that if I go to the base that comes with this system, I mean, I have the same thing. The nice thing about it, it works the same way. This is on a friable wheel, but it'll go here or it will go with the system up here. It doesn't really work just as well on either system. In this segment, we're going to cover sharpening a spindle roughing gouge. Now, spindle roughing gouges come in different sizes. This is 1.25 inches, this is a 3/4 inch, and this is a 1/2. But regardless of the size, the configuration at the tip is all the same. Now, this tool has been perfected over a lot of years to do one thing and do it very, very well, and that is to make square pieces round. And if you look closely at the tip, let's get you over here where you can see that. If you look closely at the tip, really what you have is you have two parts of this gouge. You have a flat on either edge, on either end, or either side, I guess it would be. And this is where the primary cutting point is really here as you're bringing something from square back to round. But what we want to have is we want to have a flat, and then we want to have a flat. Now the important thing is that as you're beginning to work with this on a turning, you're making it square with a dead on like this. But once you've got it kind of round, you have the ability with this to rotate the tool and use that flat section to go through and do some smoothing across the rounded surface. Okay, so now here's the key, is your hand, your left hand goes on the platform. You put 3 or 4 fingers, as many as you got left, I got 4 fingers on that hand. Put it down, put 1 finger in the center of the flute, and we're going to bring it up to the wheel gently. You don't have to jam it in there. And we're going to use the center finger to hold it in place, and we're going to kind of rotate it against the other fingers. Now, it's important that the gouge stay on the platform. If you bring it up, you change the angle at the tip on the grinding wheel. This particular platform and system is really nice in that it has graduations on the platform, and again, it has a little guillotine as well as a lockdown, so that the repeatability increases dramatically here because of the guillotine and the indexing on this platform. So all I'm going to do is set it to 40. I'm going to lock it down, turn it on, put my hands on the platform, make sure the tool is fully on the platform, bring it up, go to one edge, go to the second edge, and I'm done. Now again, it's always important that you take a good hard look at it. Now as I look at this, what I see is that right in here it isn't quite as flat as I would like, and so I'm going to put it back on the platform and go up and address that flat part to get a little flatter. I'm going to check the other side. I have the same issue there. It's a little rounded. Okay, now if I look carefully at that, what I have is I have a flat, a curve, and a flat. When I say flat, what I mean is that this is straight across. That's very important. Now, there are some differences of opinion about this edge right here. Well, let's go back in a little closer. Right here. Some folks like to leave that straight across. The reason for that is it allows them to go in close to a bead and clean it up without having to change tools. The downside to that is it also makes it a little catchy. So my practice has been to come back in once the tool is sharpened and just touch that tip and take that point out of there. So it's a little rounded. Okay. See the difference there? Okay, so that's a CBN wheel with one system. Now let's move on. Let's see, next system we're going to use is down here. And this, again, is a friable wheel. It's a ceramic wheel. On this particular system, we're going to take the jig, which we've used before on the bowl gouge, go back in, set it 2 inches off the edge. Now up here on my upper platform, I have a block of wood that's 2 inches back from the edge, so I'm able to put it up there and get it exactly 2 inches. Again, it's important that this distance always be the same. And now the next thing I've done is I've loosened the jig and set the handle on the 1 setting, which makes it almost parallel, or actually parallel to the tool. And that allows me to hold it securely. Now the bar has been set at 121. But we never know with a friable wheel whether the measurement from here to the tip of the tool is correct, because that wheel wears away and changes diameter. So we're going to take our magic marker now, and we're going to coat that tip. Now somebody asked me, well, why are you using blue? Well, the answer is I got tired of the black. No real reason. It doesn't make any difference what color it is what you have. But the key thing is it allows you to put it on the wheel and to turn the wheel in reverse by hand and go look at what you have. And in this case, it looks like I'm dead on. I don't have to make any adjustments in the bar at all. So I'm going to check my lockdowns, rotate the wheel, make sure that nothing is going to be damaged by it. Turn the wheel on, set it firmly in the base, bring it up. I don't want to jam it into the wheel, but just bring it in. And again, I'm going to go at about a 2 o'clock position, do the other 2 o'clock position, bring them together. Now, again, always, what's hugely important is to take a look at it. Now, again, what I see is this edge right here isn't straight across like I'd like. So I'm going to return it to the grindstone and work on that edge. Now, one of the things that happens here on a friable wheel is you get sparks. Now, you don't get that on the CBN wheel. And one little trick is you can tell when you're right at the edge, when you start to see sparks come over it. Now I'm seeing sparks come over the edge of the tool, so I know that I'm sharpening right at that edge, and I straighten it out. So it's a straight across there. Again, we go back to the key ingredient of this is you look, make sure you got it straight all the way across there. As always, the closer up you can hold the tool to the jig, the better control you will have. If you hold it back here like this, you just don't have good control of the tool. So get your hands up there close, and you're good to go. Okay, so now we have the second sharpening system. We have on a friable wheel, but we're not done. There's another choice on spindle roughing gouges. Sometimes you have just the platform, and this is an older style. This platform actually came with the grinder, and I'm going to use the smallest tool. Now, one thing that's important as you grind a spindle roughing gouge is that you not come in cocked. You got to come in at a 90-degree angle. Now, this is a rather small tool. This is rather a coarse wheel. So, quite frankly, I don't have. What do you want, blue or black? Let's do black this time. What do you say? All right, we got the edge of the tool marked. We're going to bring it up, same as before. I'm going to use my fingers. This provides a steady rest, and this goes into the center of the flute. I'm going to hold it up close to the wheel, and it's perpendicular on the platform, and all I'm going to do is that. So let's turn the grinder on, lock down, ready to go. Position your hands, bring the tool up. Take a look at it. Not quite there. You can still see some of the black. So I'm going to set it up again. Bring it up. Taking the edges off, and I'm good to go. Now, one question that you should properly ask is, how do I know what angle this particular platform is set at? And there are a number of different ways to make that determination. The method that I seem to use is this one, which is actually a magnetic angle finder. it really works pretty well. You just put it right on there, wait for the needle to stop bouncing, and you can see that that angle is 45 degrees. So that's exactly what we wanted, so we're good. A parting tool is one of the mainstays of turning. We use it all the time. A couple salient points I'd like to go over with you before we move to the grinder. First point is it's very important that this edge and this edge be across from each other. You need to sharpen equally on each side of the parting tool and not just concentrate on one side. If you do, over time, this point will move back and back and back, and this one won't. And all of a sudden, your point is not equidistant in the middle of the tool. All right, the second issue is it's very important that this not only be a straight line, but it be 90 degrees to the side. It's very easy to come into the grinding wheel with this tool at a slight angle. And as you do that, you've created an angle across the face of the tool. So you try to come in perpendicular to the wheel. If you have any kind of straights on your platform, that's a good thing to use to help you set your eye as you bring it into the tool. Okay, with that, all that being said, let's get started. Probably the easiest way to sharpen a parting tool on a CBN wheel that has the side grit is simply to come in this way. Now, my practice is to position the tool so that it's flat across the wheel, back it off of the wheel just slightly, turn the motor on, bring it in, and feel the flat of that wheel. Bingo, I'm done. I go to the other side, I bring it into the wheel, and I'm done. Now I'm going to look at it. I'm going to make sure that that point and that point are directly across from each other. And most importantly, I'm going to make sure that that cutting edge is 90 degrees to the rest of the tool. Now, I consider that to be the easiest way to do it. Other folks may not agree with me. And if you don't, the easiest way to do it is bring the platform so that it allows you to come up to the wheel and be dead on. Now, in this case, that's right at a 40-40 indent, so it's pretty simple. Turn on the wheel, make sure you're locked down, come up, and just move it across the wheel, flip it over, move it across the wheel. Now, if you look carefully, you can see where that's not been sharpened all the way across. So when I did it somewhat freehand versus using the platform that's engaged at the specific angle, there is a difference. So let's go back and do it again. Now, if you notice, I'm moving this across the face of the wheel, but trying to keep it perpendicular all the time, and we're good to go. This one is really rather amazing, and we've used this to sharpen a bowl gouge and a spindle roughing gouge, but we can also use it to sharpen a skew. We adjust the leg to the point where it is parallel, the leg of the jig is parallel to the tool. That allows us to go down to the base of this system, engage it to the wheel. Now, it's important that this be tight. Oh, I should talk about this for a minute. This is a parting tool, but if you look carefully, this is what they call a diamond-shaped parting tool. What that means is that it's thicker in the center, and then the thickness of the tool diminishes as you go back onto the body of the tool, and that gives you more clearance in your cut. So we're going to put it into the base, bring it up to the wheel, adjust the arm until it's directly onto the wheel, lock down or hold downs, turn it on, bring it up. One of the nice things about CBN wheels is you will get sparks, and so you can tell when the tool is sharp when you see sparks come over that edge. The second thing that happens with a CBN wheel, with an aluminum oxide wheel where they're a little bit rougher, is your positioning on the wheel does not have to be as exact, because what you do is you eat away metal till it gets to that point. That's the good news. The bad news is that over time you shorten and shorten and shorten your tool. All right, that's the second way to sharpen a parting tool. Probably the simplest in equipment requirements is here. And in this case, what we're going to do is we're going to bring the tool up, paying attention to the lines on the tool rest to help us make sure we come onto it dead on. And we're simply going to put the tool on the back of the platform, bring it up till we find the heel, bring it forward, and raise the handle until we're grinding at the tip, and stop when we start to see sparks come over the top of the tool. Flip the tool over, find the heel, bring it up, and I'm over the tip of the tool. Now, as I do that, I notice that I'm going to side on the wheel, and I don't really think about that, but I think I learned over time that if I move that tool across a friable wheel where it wears away, I will equalize the wear across the wheel by doing that. So that was a practice that I continue to have. All right, next type of parting tool is a thin kerf parting tool. If you'll notice, that is a curve, and over time that will become the diameter of your wheel. But the real working point is right here, and it's sharp as the dickens. So if we go back to the CBN wheels, release the platform, bring up the platform until you match the curve on the tool, which is right there. Lock down the platform. Come in perpendicular to the wheel. Raise up the handle of the tool until you're at the tip, and you're done. You've sharpened it. Scrapers are an important part of every woodturner's kits. Now, it's rather an interesting tool because not only do they come in different sizes, but they come in different shapes. And there's a scraper out there for every possible tight spot that a turner would like to get into. But they're all the same in one regard, and that is they don't cut with an edge. They cut with a burr. And it's really not important what that angle is right there. What's important is that there's a burr on the top of the tool, because you have to remember a scraper is presented below center so that really the wood is catching right here on the very, very tip, and it's the burr that does the cutting. Now, there's really two ways to sharpen a scraper. You know, one is on a platform, or the second way is off the lathe, which I'll show in the final segment of this video. But if we're going to use a platform, first thing I'm going to do is to bring up a angle measure, and I'm going to check and see what the current grind is. And as I look at that, it's right at about a 70 degrees. So the next thing I'm going to do is I'm going to bring up my angle meter and set the platform at that 70 degrees. An alternative to that is to loosen up the platform and then move the platform until the tool matches the wheel. Now, you remove less metal if you're able to replicate that angle exactly, because you have to get to the tip to create the burr. So on this particular sharpening system, it does not have an indent that matches my historic 70-degree grind on my scrapers, which is not a problem because you can adjust it any place that you would like to. All right, let's see. Checked, checked, checked. Nothing's loose. Turn on the grinder. Put the scraper flat on the platform. Bring the tool up to the wheel and simply rotate it across the face of the wheel. And now to check this, you actually check and see the condition of the burr, and that's superb. But let's go a little further. Let's do this one, which is a little bit larger tool. It's got a longer handle. And this time I want you to watch not only what's happening on the platform, but also have a look at what is happening with my body. So if I can get this set up correctly, you've got a double view. And you're going to see that I'm going to start with my feet apart. And I'm going to start with the tool flat on the platform, bring it up. Now, as I go around with the tool, I'm also moving my body. So, you know, it really is a full body move, and you know, because that's what that shape requires, which is why as you think about your setup of where your grinder is, it's important that you have room to be able to make those moves that you need to make. Now I want to show you one more tool. This is a scraper that's designed to complete the intermediate section of a Christmas ornament, a hollow ground. And it's a little bit different in that if I bring this up to the platform, as I come up, what I'm finding is there isn't good clearance to the platform. So I'm going to go off to the side. I'm going to bring it up, start it on the side, and bring it around and finish it on the face. I just find that's an easier move to make than trying to get it all the way across the face of the wheel. Because right there I hit. I don't have clearance on the platform. So with this particular tool, this particular platform, the grid on the side becomes very important. Now, the same thing is true. If this is a friable wheel, you don't use the size of the side of the wheel. If it's an aluminum oxide wheel, if it's a blue ceramic wheel, you run a real risk of fracture if you use the side of the wheel. But you can do it on a CBN wheel. Skews are invaluable in spindle turning. The skew not only cuts the wood, but also burnishes it, leaving a surface that needs little or no sanding. Now, if you really think about the edge on a skew, it really is, in effect, a knife on a lathe. What it has a profile on the edge, it has a bevel, and then it has metal to strengthen the cut behind the edge. Now, I want you to keep that in mind. What we're really trying to do with the skew is to get it as sharp as a knife. All right, now, where we're going to start is one of the simpler ways. If you are fortunate enough to have a CBN wheel with a side grit, what we're able to do is to actually just put the skew on the platform, come up, find the flat of the skew. Now you can see that this is just straight across. That's where that profile is, straight across profile. We're going to put it up on the wheel, find the tool, back it off the wheel, turn on the wheel, and just very gently touch it to the wheel, watching right in there to see how it matches up to the wheel. And what we end up with is a surface that looks like that, which is good to go. Now you come back in on the other side and do the same thing. Come in lightly, and the tool itself will conform to the wheel. And we're done. All right, now, if you're a little bit hesitant to freehand that, with this system you can also obtain a jig. And what this jig does, it holds the skew perpendicular to the base, and also allows you to come in just off the wheel, and you just move it right into the wheel, and you have your profile. You go to the other side of the jig, hold it in place, bring it up, and you're done. And what you have is one consistent bevel across the tool. It is important when sharpening a skew that you have one continuous surface across there. The parts of the skew that really are critical are the edge where it cuts, which needs to be razor sharp, and the heel that primarily does the burnishing on the wheel. Okay, now that's one form of sharpening the skew. If we're going to sharpen a skew that has a curve, it's a little more complicated. The first step in this process is to loosen up your platform. Start turning the platform back, and what you want to do is you want to find that same angle on the platform as you have on your skew. Now, if I do that, and if you look real closely right there, can you see how that matches up? Let me see if I can bring you in a little bit. See, that particular setting is matching the existing profile on the skew. So now all I have to do is do that. Now, by happenstance, it turns out that there's an indent on this system right that matches up with that angle, which is a 60 indent. Now, this is an oval skew. What that means is the profile isn't square across here, but rather is curved, which makes it a little bit more challenging. What we would do is bring up the tool, and we've got to go this way, but we also have to roll the tool as we do it. So it's a combination move of across the wheel and roll. Across the wheel and roll. Let's see how it turns out. Bring it up to the wheel. Now, if I did it right, it'll be one continuous surface across the wheel. You turn it over. Now, if I think about what I'm doing as I do this, I'm also actually moving my feet. I'm lifting my right foot to help me get that curve in here. So I'm not curving it with my hands, I'm curving it with my body. All right, now, that's a second way to sharpen a skew. Let's go on to the next way. The other thing that can be done and with this jig, which is kind of interesting because this jig in a lot of ways, you don't have to have a platform when you have this particular jig. Again, I've moved the arm parallel to the tool, which is a setting of 1. I've set it in to get my distance from the tip to the jig itself. Now I'm going to go down to the base. Again, the first thing to do is to adjust the base so that the profile of the tool matches the wheel itself. Next thing is we're going to do is turn on the motor, and we're going to bring up the skew. Our hands are going to be high up on the jig. And it's that same rolling move across the face of the wheel. With that side done, we turn over to the other side, find the wheel, move it across the wheel. Now, when you use a aluminum oxide wheel like I just did, what you find is a benefit of you can tell when you're right at the edge because the sparks go over the edge of the tool. And what that means is that your alignment doesn't have to be spot on. It can be a little bit off because you're going to take off metal until you see those sparks come over the edge of the tool. Now, that's the good news. Bad news is over time, because you're never exactly dead on your alignment, you lose metal until the tool is all used up. With the CBN wheels and systems that allow greater repeatability, you can use a finer grit and you just lose less metal. Knowledge of how to sharpen your tools by hand without a grinder is an important part of a turner's library of sharpening techniques. There's a couple reasons why. The first reason is it's quicker. Yes, I know you got your sharpening station no more than 2 steps away from your lathe, but if you can simply pick up a diamond card and sharpen a tool and go back to turning, it really just works better. The second thing is that all of the grinding, all of the diamond cards and stones and sticks go to a higher grit than typically we have on our grinding stations. So it's not unusual to have a 180 and a 320 or a friable wheel of a 120 and a 180, but those are relatively coarse. And the diamond cards or diamond hones or diamond sharpening tools all will bring you to a sharper edge, which makes those curls fly so much better. Okay, so with that as an intro, let's get to it and pick up where I left off before, where I had said that my habit is to sharpen my skew with a diamond card, and I haven't put it in a grinder for several years. Let's switch over here. All right, now what we have here is a number of different diamond tools. This is a diamond stone. It's relatively large. It works really great for bench chisel. These are diamond cards. Typically they come in sets of 3, a coarse, a fine, and an extra fine. I particularly like this card. This card is a 400 grit on one side, and it's a 600 grit on the other. I mean, it just makes it fewer pieces of stuff to carry around. This is a cone shape diamond stick. This is a ceramic rod. And those are the primary sharpening tools that we find out there. Now, let's go back to my skew. This was the most complex one. It's an oval skew that has a rounded tip. And it takes a bit of practice on the lathe to get to the point where you can get that sharpened just to a very fine, consistent edge. So instead, what we're going to do is we're going to pick up a diamond card, and we're going to go to a 400 grit, and we're going to put it across the, let's bring you in a little closer. Going to go across the bevel, find the bevel, position the card, and go switch it over, find the bevel, ride the bevel with your card, switch it over to the 600, and again 600, Now earlier we had talked about the sharpener's look. Well, in this case, it's the sharpener's thumb. So you feel the, oh boy, that is sharp. I mean, that is ready to really cut some wood. And so it's up to you. What I found is that for prolonged periods of time with a fair amount of usage, it works quite fine on the card. Okay, so that's an oval skew with a curved face. Let's not stop there. Here is a round skew. What we have is a round bar. It comes to a point across it, so it becomes a skew. And I'm going to do the same thing. I'm going to go to my diamond card and go and it's as sharp as the dickens, and the points are quite crisp, which is very important at times. The points are crisp. All right, so that's the round skew. Next, let's go to a bowl gouge. Now, bowl gouges come in different flutes. This is a ceramic rod. There's various different grits out there. The white rod, which is the finer grit, is the one that's appropriate for wood turning. But you can put that right inside the flute. Now, if you notice on camera, hopefully, you'll see that that ceramic rod matches up with the flute of the gouge. So all we have to do is, and we're sharp. Now, it doesn't always work that way because flutes are different. There are different types of flutes. So if you have a narrower flute, this is where this cone shape diamond sharpener comes in handy, because now all we're doing here is taking the diamond cone and running it in this narrower flute. Now because this goes to a very small diameter, this will also work on spindle gouges. This is a scraper. Now this is going to surprise you, but you have to remember that a scraper really is cutting right there on that burr. And that burr wears away very rapidly. So what we can do is we can take a diamond card and give it upward strokes across the edge, riding the bevel as we do it. And we've actually can raise that. Yeah, that is raised right back up. We have that burr back, but I'm not done. So let's take that burr back off of there again. So now it's just a flush edge. And what we will do is take a bowl gouge. Now this is a relatively newer generation of bowl gouge where the metal is quite hard. On the Rockwell scale, it is harder than the older gouges, but all I have to do is simply put some pressure on that and run it across that edge, and this will raise that same burr. Burr's right back. So the moral here is sometimes it doesn't take more tools. Sometimes it's just knowing what to do with what you have. Yeah, that's fine. It's ready to go. Okay. Next up are these. Now this is a high-speed steel teardrop scraper. And normally when you see those, it's in a handle that looks like this. I'm going to take the top edge, the edge that has the cutting, or the top that has the cutting edge, put it face down on my diamond stone, and do a few figure eights. You can use water as a lubricant on this, or a lubrication oil, a light oil, that's made specifically for diamond stones. It kind of saves the wear on the stone. But as we do that, we've sharpened up that edge that's worn away, and we're good to go. Now, in today's world, carbide is quite common. And when a carbide cutter gets dull, it needs to be replaced, or it needs to be sharpened, because yes, carbide cutters can be sharpened. Carbide cutters cannot be sharpened on a CBN wheel or on a friable wheel. The carbide is harder than either the CBN or the grits or in friable wheels, but a diamond stone works. So if you start to sense that your carbide cutter is dull, simply put a little lubricant on there, do the same thing, few figure eights, and it's absolutely amazing how that will refresh the edge. It makes all the difference in the world. All right, but not all carbide cutters are flat like that. A lot of them are round, like this one is. Let's get you even in a little closer. See that carbide cutter? Now, this is what's called a stem sharpener. And what we have is a screw that's the correct size to fit in the middle of the round carbide cutter. We're going to take it and tighten it into the threads so that it's firm. Like that. Slide it into our chuck. Now this is what's kind of interesting. We're going right in the center of the chuck. Regardless of the jaws, regardless of the size, regardless of the make of the chuck, you can slide this stem sharpener right in there. Lock it down snugly. Turn on your lathe. And what we want to turn the speed down, but not all the way to just dead slow. And we're going to bring up our diamond stone or diamond card, find the bevel, and just let it run itself across that bevel. And with just that, what we have done is resharpen that carbide cutter. It is amazing all the techniques that a turner really needs to have in their library of sharpening methods. But, you know, tools and jigs and stones are all fine, but at the end of the day, there is a place for hand sharpening also, and it's good that you have it in your library of sharpening methods. In closing, I want to kind of reiterate what I started with, which is, you know, sharp tools just bring fun to wood turning. And if you're getting frustrated, sometimes it's just the fact that you haven't sharpened your tool. So take the time, get a sharp tool, and those curls just go over your shoulder, and that's a great joy. Thank you for watching.